In the last session, we discussed about the power flow equations of the synchronous motor. So in that, we will get some equations, that is the apparent power S equal V square by Zs at an angle of theta minus EV by Zs at the angle of del plus theta. Okay. Next, we will continue the same thing, that is, so we will divide into active power as well as the reactive power. So what we will get, we have to discuss here. So we will extend this. The equation is like this. So we will extend, the equation will be like this. The equation is, then we modify the angle, then it will become like this, that is v square by zs, then at an angle of theta will become like this, cos theta plus j sin theta, minus, next another thing, ev by zs, here cos theta plus del plus j sin theta plus del. So cos theta plus del plus j sin theta plus del, or del plus theta, theta plus del. And now we will divide into active parts and reactive parts. Here the active parts is, this is the active part and this is the active part, remaining is the imaginary part. So active part I will write like this, v square by zs cos theta minus, this is the one point, and minus ev by zs cos theta plus del, cos theta plus del, plus if you common j, if you common the j, then v square by zs sin theta minus ev by, because here the minus is there, ev by zs sin theta plus del, sin theta plus del. So from this we will write the active power and reactive power. So this is the active power P, yes, and this is the reactive power Q. So finally we will write P and Q like this. The active power P equal, so from this if you common the V by Zs, so we will get V by Zs, and remaining is V cos theta minus E cos theta plus del, and Q value equal, if you common V by Zs from this, same thing, V by Zs, here V by Zs, here V by Zs, the remaining is V sin theta minus E V sin theta minus E sin theta plus del, sin theta plus del. So here, so this is the active power, this is the reactive power. From these both cases, we know that armature resistance is approximately 0, then the synchronous impedance will approximately Zs at an angle of theta will become Xs at an angle of 90 degrees. Xs at an angle of 90 degrees. Then we will divide active power and reactive power is like this. So here the active power V equal V, replacing the Xs here, and V cos theta value is the 90, this is the cos 90, next E cos 90 plus del, one thing, and Q value equal to V by Zs will become the Xs, and V sin 90 minus E sin 90 plus del, 90 plus del. So from this we can find out V equal to cos 90 value 1, cos 90 value 0, so cos 90 plus theta sin del. So this value is 0, and finally we will write V by Xs into E sin del, E sin del. Then Q value equal to sin 90 value 1 here, sin 90 plus del value cos del. Okay, so from this we will write V by Xs minus V into E cos del. E cos del. So these are the approximate active power as well as reactive power. This is the P value and this is the Q value. These are general useful equation by doing the problems. These are the very important equations. In case of so not E sin del or EVX sin del, right? Next, condition for maximum power input. Maximum power input. How to find out the maximum power input? So whenever we are doing the differentiate the input with load angle, then we will get the condition for the maximum power input. So here input, we are differentiating the input power with respect to del. Here d by d del. What is the input power from here? Input power, look at here, input power. So here we have the input power. This is the input power. You should consider this power. This is the power v square by zs cos theta ev zs by cos theta plus del. So write that formula, that is v square by zs cos theta minus ev zs cos theta plus del. Cos theta plus del. So then it should equate to 0. Then so this is the del, there is no del term, so this become the 0. Next, ev by zs is the constant and cos theta plus del will become minus sin theta plus del, minus sin theta plus del. And by doing for theta plus del, theta value 0, del value should be 1, equal to 0, equal to 0. So into this is okay. So finally we will get ev by zs sin theta plus del equal to 0, equal to 0. So we will write this value is, we can write it sin 180. Why we are not taking sin 0? Because theta plus del value more value, that's why we will taking like this. So from this we will write theta plus del value equal to approximately 180. So from this we will find out del value is 180 minus theta. So del value is the 180 minus theta. So by using this del value, so we will substitute in the input power. So this is the input power. When we substituting, we will get the some value. So just substitute 180 minus theta here. By substituting this value in this equation, the complete maximum power input. So we will get maximum power input value. Power input equal. So we will write P input maximum equal V square by ZS cos theta, and substituting 180 minus theta, cos 180 1. So we will get EV by ZS, EV by ZS. So this is the formula for the maximum input power. This is the formula for the maximum input power. Okay. Next is maximum power developed, maximum output power developed, maximum mechanical power developed or output power. So it is generally, it is a synchronous motor. Synchronous motor will take the input power and it will generate the mechanical power, but mechanical power should be, you should take in terms of the EMF induced across the armature E and with respect to armature current, so we will write the mechanical power developed formula equal like this. The mechanical power developed formula equal active component of EMF induced and armature current square. We will write armature, so that means conjugate of current square. So from this we will write like this: the active component of E, we will write at an angle of minus del, and V by Zs at an angle of theta minus E by Zs theta plus del, theta plus del. Okay, so from this, by solving this, we will directly write the mechanical power. The mechanical power value equal, the mechanical power developed equal EV by Zs cos theta minus del minus E square by Zs cos theta. E square by Zs cos theta. This is the mechanical power developed. This is the mechanical power developed. Okay. So in this class we discussed about for the extension of power flow equations, and in that we discussed the active power P and the reactive power. With that and we discussed about the formula for the maximum mechanical power developed, maximum input power developed, and we find out the equation for the mechanical power. Okay, I think all of you understand the session. Thank you.